Welcome to Easy Learning Simplified. My name is Ruth, and our topic for today is called chemical families. We're going to be looking at the alkaline earth metals and the properties. We are going to be looking to their chemical properties. So, this is a continuation of what we have been discussing in the previous lesson. We discussed some of the properties of alkaline earth metals, like reacting alkaline earth metals with air and water, both cold water and also steam. So for today's session, you're going to continue with these properties and then later on look at some of the uses and then do a few questions. So next, you're going to look at the reaction of alkaline earth metals with chlorine. So alkaline earth metals usually react with chlorine to form chlorides as the only product. So what you notice in this reaction, we need to have heat present because the metal needs to be heated first. And then this reaction needs to be carried out in a fume chamber. The reason why it's being carried out in a fume chamber is because chlorine gas is very poisonous. So for example, if you look at magnesium, magnesium is placed in a defragrating spoon and then it's lowered in a gas jar containing chlorine and then the reaction continues. What you notice with magnesium, it continues to burn with a brilliant white flame and it produces a white powder. This white powder is because of the formation of magnesium chloride. So this reaction is very exothermic. That's why you see that white brilliant flame. So the heat will keep the metal burning and then it will cause the magnesium to react with chlorine to form magnesium oxide. So the equation for the reaction is magnesium reacts with chlorine to form magnesium chloride, as you can see in the equation. And you see the equation is balanced. You see, at the same reaction with calcium, it is also placed in a defragrating spoon and then lowered in a gas jar as well, containing chlorine. And then the reaction is allowed to take place. So the metal burns with an orange flame, but soon smolders off. And then when you look at the reaction between calcium and chlorine, heating usually helps in the reaction, but because calcium is coated with an oxide layer, it takes a lot of time for that reaction to occur. That's why we say it's not steady. It prevents that reaction from occurring. So, but under like specific conditions where, like for example, the calcium has been cleaned off completely, the reaction between it and chlorine usually forms a white powder, and that white powder is referred to as calcium chloride. So if you look at the equation also for the reaction is calcium reacts with chlorine to form calcium chloride, and you can see the equation also is balanced. Next, we look at the reaction of these metals with acids. So, and specifically dilute acids, because you know for the concentrated acids, the reactions are going to be very highly reactive and explosive. So when these alkaline earth metals react with dilute acids, they usually form salt and hydrogen gas. Example, when beryllium reacts with hydrogen gas, hydrochloric acid, sorry. So beryllium solid reacts with hydrochloric solution to form beryllium chloride. You notice because of the valency of beryllium is 2 and chlorine is 1, that's why the solution formed is like this. This is a 2 and this is an aqueous solution, and also hydrogen gas is given off. So when you are balancing this equation, you notice there's two chlorines on the reactant. So we need to put 2 in front of hydrochloric acid to balance the chlorine. This 2 also helps in balancing out the hydrogens. So now we have 2 hydrogens in reactants and the 2 hydrogens in the product. So you notice this reaction causes the production of effervescence. The effervescence is as a result of production of hydrogen gas. This hydrogen gas can be tested by a burning splint. It's going to burn with a pop sound. And then next, another example is magnesium. So this reaction is going to be magnesium solid plus hydrochloric acid, which is aqueous in state, to form magnesium chloride, aqueous, and hydrogen gas is given off. So you'll see effervescence because of this production of hydrogen gas. And you said you can test it, it's going to burn with a pop sound. So if you balance this equation, it's going to be still the same with beryllium. Just put 2 in front of hydrochloric acid. And then we go to calcium. If you react calcium with hydrochloric acid, it's going to be calcium solid plus hydrochloric acid to form calcium chloride and hydrogen gas. So the balancing is still the same. So that in the reaction, when you add that solid in the acid, you're going to see effervescence because it's production of hydrogen gas. And this hydrogen gas can be tested with a burning splint and burns with a pop sound. The metals also can react with sulfuric acid, sulfuric 6 acid, but remember these are dilute acids, so we do not use concentrated. So if you are reacting beryllium, it would be Be plus sulfuric acid to form beryllium sulfate, which is also aqueous. Remember the valency of beryllium is 2 and valency of sulfate is 2. We did this when you were doing the introduction bit of Form 2 and writing the chemical formulas. You can check that out. Plus hydrogen gas. So if you look at the equation, we have 2 berylliums both sides, 2 hydrogens both sides, 1 sulfur both sides, and 4 oxygens both sides. So this equation is balanced. But when you look at the observations for the reaction, you're going to see effervescence because of production of hydrogen gas, which burns with a pop sound. So magnesium also reacts with dilute sulfuric acid. So magnesium solid reacts with sulfuric acid to form magnesium sulfate plus hydrogen gas. So you notice also this equation is balanced. Magnesium is 1 in both sides. The hydrogens are also equal in both sides, and the sulfurs are equal and oxygens are equal. So in this reaction also we are going to see some effervescence, and is as a result of the formation of the hydrogen gas. Finally, a reaction of calcium with sulfuric acid will be a bit different. So when you drop it, you're going to form a slight effervescence, and note the word slight effervescence. This is because there is little or no amount of hydrogen gas produced, which when you expose it to a burning splint, is going to burn with a pop sound. However, the reaction usually starts and then stops. This is because of formation of a precipitate. This precipitate coats the metal and then the reaction stops. So what is a precipitate? We are talking about the precipitate that coats the metal and it is usually insoluble in nature, is called calcium sulfate. This is the one that stops the reaction from going on further. That's the reason why I told you that for the reaction of calcium with dilute sulfuric acid is a bit different in comparison to the other acids. So when you look at the reactivity of alkaline earth metal, you notice that the reactivity increases down the group as well. This is because the atomic radius, you see we always start with atomic radius. The atomic radius increases down the group as well due to the increasing number of energy levels. This causes the attraction of the valence electrodes towards the positive nucleus to decrease. So in calcium, the outermost electrons are held very weakly by the positive nucleus, while in beryllium, the outermost valence electrons are held strongly. So alkaline earth metals usually lose electrons when they react. So the ease of loss decreases. down the group. So you are able to lose very easily, or the ease of loss increases down the group. So beryllium loses easily, magnesium loses even easily, and then calcium loses even easy than um, magnesium and beryllium. So if you were to compare the reactivity of alkaline earth metal and the reactivity of alkali metal, we would say that the reactivity of alkali metal is more in comparison to alkaline earth metals. Remember, alkaline earth metals, they are losing 2 electrons. For alkali metals, only 1 electron is being lost. So you know that even losing those 2 electrons is not that easy because we have two ionization energies. It will require much, much more energy. But for alkali metals, we're only losing 1 electron. That's the reason why we don't require as much energy. So that's what we learned. Then when you look at the compounds of alkaline earth metals, they have the same kind of formula because of their valency is the same. For example, beryllium hydroxide will be beryllium. Remember we said we put the radicals in bracket and you put 2. Magnesium will be the same. You put the OH in 2 and then in bracket, and then calcium will also be the same. You put the OH in bracket. So the brackets are only possible if the radical is more than 1. So beryllium oxide, the 2 will cancel because the oxidation number of oxygen is also 2. Magnesium oxide will be the same. The oxidation number of the valency of magnesium is 2 and oxygen is 2, so that they cancel each other. So calcium is still the same. Beryllium chloride, the valency of chlorine is 1, so and the beryllium is 2, so this becomes the formula. So the same applies also for magnesium and calcium. For sulfate, both sulfate and the alkaline earth metal, this is alkaline earth metal, are 2, so it becomes beryllium sulfate. It cancels out, and then magnesium sulfate and calcium sulfate. So this is just a general formulas. There are also other ions that you can react with. This is just a sample. You can go back and practice with the topic that we discussed previously. So let's look at some of the uses of alkaline earth metals. So just like we said for alkali metals, when you asked for the uses, you need to be very specific with a specific metal. So magnesium is used in the manufacture of magnesium hydroxide. This magnesium hydroxide is used as an antacid medicine. And then magnesium and aluminium are usually used in constructing aeroplanes. Hydrated calcium sulfite is used in setting fractures. It's also known as the plaster of Paris, commonly known as that. And then calcium carbonate, which is limestone, when mixed with sand and clay, it is used to form cement, which is used for building. And then calcium carbonate also is used in the extraction of iron. We will learn more about this when we look at extraction of metals, especially metals that are below the reactivity series in Form 4. We see the calcium carbonate helps to produce the reducing agent. And then calcium oxide is used to increase the pH of soils. This is a very common application question. Calcium nitrate is used as a fertilizer. Magnesium oxide is used in lining furnaces. Barium sulfate is used in diagnosis of ulcers. Barium nitrate is used in production of fireworks. Calcium carbonate mixed with oil is used to make putty. You can see how much calcium carbonate is being used. So after that, we go and look at a few questions. State and explain what is observed when a piece of magnesium is lowered to a gas jar containing dry chlorine gas. So basically, we are explaining what we see. So one of the things that we see when that happens is a white blinding flame and a production of a white powder. So if we explain is the reaction is very exothermic. That's the reason why it continues to burn and it's burned to the blinding flame. So when the magnesium reacts with chlorine, it forms magnesium chloride, which is the white powder. Step 3, uses of alkaline earth metal. We have just discussed that. Make sure you go and check. Make sure you get at least 3 uses that can come in the exam. But as you get to Form 4, you notice that the uses decreases. You'll be required to know at least 2 uses for you to be well prepared for the final exam. Explain the trend of reactivity of alkaline earth metals. So we said that their reactivity is that it increases down the group. And you said the reason why it increases because there is an increase in the atomic radius. So if there's an increase in the atomic radius, the valence electrons are held weakly by the nucleus. So you can talk about the positive nucleus. So they are held weakly down the group. So it's very weaker in calcium as in compared to beryllium. So if they're held weakly, it means it's easier to lose the valence electrons down the group. And that answers the question. So that brings us to the end. So we are done with alkaline earth metals. The next group or chemical family we are going to be looking at is halogens. I hope you have been able to see those properties. See you in the next session.